Hey guys, it's Mr. Chu, and here's what you're going to learn today. By the end of this video, you should be able to solve a matrix using row echelon form. We have a system of equations. If we're trying to get this in row echelon form, the first thing we need to do is actually convert this into a matrix. Now we have x, y, and z as our variables, so the first column is going to be for x, the second column is going to be for y, third column for z, and the column after your bar is going to be the constants. In equation 1, we have 0 x's, 1 y, negative 5 z's, and we get 15 as our constant. So I have 1, 2, negative 1, 7, negative 3, negative 1, 2, and 10. Row echelon form again. We want 1's in our diagonals and 0's under each of them. So the first rule that I'm going to implement here is I'm going to switch row 1 and row 2. And the purpose of that is I'm getting a 1 in the first spot and a 0 right under it. So I wind up getting 1, 2, negative 1, 7, 0, 1, negative 5, 15, negative 3, negative 1, 2, and 10. My next rule, what I'd like to do is I'd like to start working on row 3. I have a 1 in row 1, I have a 0 in row 2, I need to get rid of that negative 3 in row 3. So what I'm going to do is I'm going to alter row 3, and the rule that I'm going to implement is going to be 3r1 plus r3. And so the matrix that we get with this rule is going to be 1, 2, negative 1, 7, 0, 1, negative 5, 15, 0, 5, negative 1, 31. Now our goal is going to be, we need to get rid of that 5 in the third row, second column. We're going to work on row 3, and what we're going to do is, let's go ahead and multiply negative 5, row 2, plus row 3. The matrix we get, 1, 2, negative 1, 7. 0, 1, negative 5, 15, 0, 0, 24, negative 44. We now need to turn that 24 into a 1. And so the rule that I'm going to implement, we're going to change row 3, and we're going to multiply row 3 by 1/24. Or we can say we'll divide each term in row 3 by 24. The matrix that we get as a result is going to be 1, 2, negative 1, 7, 0, 1, negative 5, 15, 0, 0, 1, and we get negative 11, 6. This is a problem where we do get fractions as our answers. If we rewrite that augmented matrix, that last one, as our system of equations, we wind up getting 1x plus 2y minus 1z equals 7. We'll also get y minus 5z equals 15. And then we have z equals negative 11, 6. So we have one of our variables solved for. We can go ahead and substitute that into one of our equations. We'll go ahead and substitute z into our second equation. So we get y minus 5 times negative 11, 6 equals 15. We get y plus 55 sixths equals 15, or y equals 35 over 6. Now that we have two of our variables, we can substitute both of those values in to our first equation and solve for x. So we get x plus 2 times 35 over 6 minus negative 11 over 6 equals 7. When we simplify, we wind up getting x plus 35 over 3 plus 11 over 6. And finally, our solution for x is going to be negative 13 halves. So our three answers are x equals negative 13 halves, y equals 35 sixths, and z equals negative 11 sixths. Now how do we know if we're right? Well, we can take each of those three solutions and substitute those values into the original equations. Once you do that, you'll see that we do get true statements for all three equations, which means all three solutions are correct. And that's it.